Hi everyone. This is sheetal hanjura, and I'm presenting a topic on microservices. I work as an engineering manager for VMware for their product known as VCF, VMware Cloud Foundation. So how I'm going through this engineering manager is around the microservices implementation. Okay. So then let me start and give certain background on the how does a company aligns on the strategic goals and what are the design and delivery principles. When I talk about the strategic goals, the company really wants to move fast. They want to basically enable your scalable business. They want to enter the new markets and support innovation in the existing markets. What are the design and delivery principles? When I talk about design and delivery principles, they are basically what are the agile methods they want to apply, what are the eliminate integration database and small independent services and continuous deployment. So these are basically the strategic goals on which the company or an organization is moving, and these are the design and delivery principles. So generally, if the company wants to move fast and they want to have enable a kind of a scalable business, then there are certain design and delivery principles on which our architecture should get aligned. Am I audible enough? Okay, okay. Thanks, Flora. The thing I'm going over is okay. I have spent a lot of Okay, so let me give you a brief on how does my experience has evolved in terms of monolithic application. So I'll take you back in the history where we started building our monolithic applications way back in 2005. So the application used to start very small, nimble, and grown over a period of time. It used to run as a single thread or a process. And if you want to change one thing in a system, you have to basically rebuild the entire application. When I say rebuild the entire application, it's basically you have to completely rebuild the entire web archive file or an enterprise archive file. And I'll take you a personal example where basically we were building an application for a big bank, which is MX. And then we had put the application in production, but the challenge was like there were certain middleware changes that we need to do. So we had to bring the entire system down, build a small JSP page through which we are giving it is like it's not available for some time. Build that page, bring the entire application down, which is not the right way. So these monolithic application existed for quite some time, and then there was an architecture pattern which was like service-oriented architecture pattern, which is defined as SOA. The monolithic application were like cut, copy, and paste. When I say cut, copy, and paste, the same architecture can be applied to different domains. And when I say different domains, it could be a banking domain, it could be a financial domain, it could be an e-commerce domain, or it could be a healthcare domain. It was a similar, and there was a transition in terms of like scaling the application. How do we scale and cut the application? Layer, there is a middleware layer, and there is a backend service layer. And this was entirely being developed by a set of engineers. There was one of the major drawback in building these monolithic application was there were only few set of developers who knew like this is the application. They knew from the scratch. So if few set of developers have onboarded while the application is being built from scratch, those are the set of people who knew about the entire application. And since now this application was huge, it obviously takes a longer time to initialize that application. And if you have to change a small UI component, and generally the UX experience evolves, and if you have to change a small UI on a front-end application, we have to completely rebuild as an ER file, as a WAR file, and then completely deploy it. So this was my major experience has been with banking industry, working across different banks as Bank of America and MX. And these are the set of applications I have seen over the period of time. Okay. Now coming back, this was monolithic application in the year of 2005 to 2008 and 10, then the service-oriented applications architecture came up. Now coming to the what are microservices? By the definition, if we go, it is basically small autonomous services that work together and are modeled around a business domain. And when I say small, what do we mean by small? Small means is it the number of lines of code? Does that small applies? Small means is it the team size? Small. With respect to microservices, here the small word means if I have to change my microservice module, does it take me more than a month to completely revamp that module. So ideally, the word small here means if I have to change a microservice module, it should not take me more than 4 weeks completely revamp that application. Okay, so that's the word small here means by word microservices. And when I say they work together and are modeled around a business domain, so there are two things that we need to very clearly understand in terms of business domain and the bounded context. And I have my further slides in terms of defining how does a business domain matter in a microservice architecture pattern, and what do you mean by bounded context. So let me just walk you through in terms of how does the microservices are modeled around business domain. When I say business domain, there is a financial, because I have mostly worked in the financial industry and now I have moved to VMware for their cloud applications. So when I say business domain, it could be a financial domain, e-commerce domain, or a healthcare industry. Okay, and when I talk about, let me take an example of financial domain. So you have customer, you have deposits, loans, rewards, investment, payments, and bill pay. These are the different entities on which this this financial domain is. And these are the language which the product team also talks about. And then there is a bounded context. When I say investment, under investment, there can be different sub-entities on which the investment portfolio aligns. So this is from the business side on which domain we are aligning and what is the bounded context. When I talk about bounded context, it means a kind of an artificial boundary around which our entities should be aligned. So this is one of the principle on which the microservice architecture should be aligned, is that we should first identify in which domain we are working and what are the different bounded contexts. What it will help us basically is once we define our domain and bounded context, our technical implementation will also look in a way is like aligned with these business languages. And with this, what happens, the REST implementations are quite stable if we define these REST implementations around the bounded context. So before, this is one of the 8 principles around which the microservices architecture should be aligned, is around the domain-driven business design and the bounded context. Okay, this I'll take you an example of where we kind of had a culture of automation. So before we built on microservice, I'll give you one example where we were building microservices for our financial applications. We basically built 2 microservices over a period of 3 months. We were good. We were happy with the content and we delivered those 2 microservices. Over a period of time, we built another 10 microservices over a period of 9 months. We got another good confidence and then gradually moved it to 60 microservices over a period of 18 months. The flaw which we discovered during this progress, and it was more of a hockey stick implementation, from 2 to 10 to suddenly 60 microservices we have built over a period of 18 months. What we lost here is we didn't put enough thought on the culture of automation. And when I say culture of automation is, do I have an infrastructure automation in place? Or do I still need to go ahead and raise a request to procure our machines? Is my automated testing, the functional test, the unit test are in place? And is my every code which I'm checking to a repository is a release candidate or not? So if you consider all these things, the idea, the one of the second principle on which the microservices should be built is before adding your fourth or fifth microservice, you should build a culture of automation should be in place. We should be able to easily procure our machines or our VMs or our containers, and every check-in should be a release candidate. This is super important because otherwise we are spending a lot of time in our development of building our new microservices, but we are not spending time in doing the infrastructure automation. Okay. The third principle that you should build your microservices is hide your implementation details. When I say hide your implementation details is, let's say you have a microservice one and it is talking to a database and getting all the details. Let's say the database has payment related information and you have a microservice one which gets all this information. Now, suppose there is another second microservice which wants to get some additional details about the payment history or the transactional details. It also starts talking to your DB directly. Instead of talking, and this is good if you have one or two microservices, but let's say if there are 10 microservices and all 10 microservices are talking to the DB. So instead of going and talking to 10 microservices to the same DB, and suppose there is a change in schema, or if you want to change the column name, you have to go ahead and basically change all these 10 microservices, which is not the right way to do it. Now, looking on the right-hand side, this is the approach that you should take. Hide most of your implementation details behind your microservice. And if any other service wants to get any information from microservice one, it should talk to the service rather than talking directly to the database. So this is a very critical, I would say, principle on which the microservice architecture pattern should be implemented. The services should interact with another service to get the data internally from their backend database. They should not directly talk to the DB and get those details, because if there are 100 microservices and if there is a change in schema, change in the column or change of any, you have to bring the DB down and go ahead and modify all these 50 odd microservices. Okay. The next principle which I want to give you an example is deploy independently. When I say deploy independently, the ones which I have put is the host could be a machine, it could be a VM, or it could be a container. If you are deploying one service on a particular host on the right-hand side, which I have mentioned, and if you are dependent that the other 4 services needs also deployment on the same host, fix that first. Because it has a binded basically continuation that all 5 services should be deployed first on that host. On the left hand side, it should always be one microservice should be tied to host. And when I say host here means like it's a isolated environment or isolated operating system, and where it could be a virtual machine, it could be a container. And during this time, the Docker technology came and kind of had a very good review on the Dockers, how they can be aligned with the microservices. So always deploy independently with a particular host or a virtual or a container, so that they get an isolated environment and you are able to take these services in the production. Okay. Uh, the next principle which I want to talk about is consumer-driven contracts. This is very important because if you're making one service ready for production and there are n number of services which are dependent and you're making change, let's say, to the payment service, the consumer of the payment service should be aware, are my expectations run against the payment service? So reward service has a set of expectations from the, and these set of expectations are basically given as an executable in terms of unit test, in terms of functional test to the payment service, and these can be integrated in your CI/CD pipeline. So in a way, when a change in the payment service is gonna get into production, are all my consumers being tested effectively so that I haven't broken any functionality? This is important because we are talking about fast changing environment. We are talking about the environment which needs to scale. So any kind of expectations should be well defined by the consumer, so that the other provider of the service, when it is making those changes, it can run these expectations, and then it can basically go and execute this as part of CI/CD pipeline. So this is important that we define these consumer driven contracts. Here I have shown like one expectation which the reward service has on payment service. There could be another service, let's say on the deposits or on the bill pay. Those also have a list of expectations from the payment service. They should be executed before the payment service goes and kind of deploys it in the production. Okay. The next thing is coexist endpoints. There are cases where you have to break your customers, and over the period of time, the versions of the service is going to change and evolve from version 1 to version 2. So basically, let's say I have a payment service which is on version 1, and over a period of time, there are there are improved enhancements or improved methods through which we can do the payment. So we move to the version V2. And how does the reward service know, or how the any other service knows that it has moved from version 1 to version 2? Either we should give the end customer sufficient amount of time so that it is moving from version 1 to version 2, and we have to basically keep both the code bases ready, and give them as a repository in the Git, have both the code bases available. And over a period of time, we can slowly move all our customers from version 1 to version 2. One of the important principles on which the microservices should be implemented is decentralize all of the things. When I say decentralize all of the things, the number one thing is freedom. Freedom for the engineers to choose what is the tech stack they are building on. So this is super important in terms of the technology, the right kind of use case, the right kind of tech stack they want to build their applications on. Self-service. There should not be a ticketing mechanism to basically procure your machines. It should be like self-sufficient. Initially, what we had is, in terms of governance, we had an enterprise architect who is basically seeing everything, like how the architecture and the design are happening. Instead of that, there has to be a self-governance or a self-governing team of people who are looking what kind of implementations we are doing and what are the right strategies to do it. And there is a wonderful tool, Swagger, in terms of having your Swagger basically for your documentations and those things. So decentralize all of the things in terms of one of the principles on microservices. This I'll give you one very practical example in isolation of the failure. So we were building an application, and it was basically taking 30 to 60 concurrent requests, and it was talking to the downstream systems. And suddenly one fine day, the request reached from 30 to 60 to almost more than 900 concurrent requests. So what was happening, the downstream one of the service was consuming more of the resources, and it was consuming all the compute intensive resources. And during this time, the service slowly, all the threads started consuming and redirecting to this microservices one, and it brought the whole of the application down. It took a good amount of time to find out the root cause, which is the service who is consuming the maximum number of resources. So it's very important that you isolate the failure. What we did is, like, we fixed the timeouts. The timeouts were really bad in terms of it were taking almost 2 minutes to get the response back from the downstream systems. There was only one thread pool for all the service which was handling the concurrent request. We fixed that, and we gave multiple thread pools and to basically align with each of the service. And we also introduced certain kind of circuit breakers, which were kind of, in case there is an issue with one particular microservice, it disconnects from the other whole of the system. While we are fixing it, it does not bring the whole system down. Okay. The one principle is on aggregation, monitoring, and observing. The things which, now that we know the other principles in terms of our bounded context, domain driven, hide your implementation details, deploy independently, consumer driven contracts, and we have built this huge system which is over, let's say, around 100, and if there is an issue, how do we log those? So log is very important in terms of either you have a tool, you can have a Kibana as a log aggregator tool, you can have stats which are pulled as a in terms of Splunk as this thing, or you while we are building your sixth or seventh microservice, you have a correlation ID or an ID basically which tracks all the way the request and the response are going on. So this is important in terms of, I would say, in aggregating your logs, finding out the latency, finding out your performance, finding out how the responses are coming from other microservices. So you are basically logging everything around your microservice path. Now that I have talked about on the principles of microservices, when do we actually have to use the microservice? The topmost reason I would suggest is if the need is for scaling the applications. And when there is a need that you have to deploy multiple instances of the service, the business requirement is it should be highly scalable. The microservices are the right architecture pattern. Independent deployability, you have to deploy and move fast in an agile world, move to the new markets fast, go ahead and independently deploy these microservices. And if you need organizational autonomy, giving full freedom to the engineers in thinking what is the right stack, the right technology, what is the right language we should use, then we need to go ahead and have microservices. Here, I'll give you some insight on like what are the advantages of microservices. One is technology heterogeneity. You can use any, if your use case demands of an SQL based database, or if there is a need for NoSQL database. Under NoSQL, if there is a need for document store or graph store, you can decide what is the right database your service should talk to. And similarly, from the scaling perspective, if you are thinking like, for example, I have a microservice, let's say post, pictures, and friends. And post should have only, let's say, two instances of the service running. Pictures should have more instances of the service running, and friends should have this thing. You can easily tune these different instances for a particular service. So these are two important things in terms of technology heterogeneity, resiliency, and in terms of scaling. Okay. The parting words is what it actually gives you is it gives you more options and more decisions. So you have an architectural design pattern where you basically have more options, more decisions. What is the tech stack? How do I want to deploy it? What is the automation I have to implement? What is the consumer driven contracts? And it does not give you like you have to start a big bang rewrites, but a series of changes made to it. So at the parting word, I would just suggest like change is inevitable, embrace it. And microservices, in case you have a small change in the UI application, you can just go ahead and change that scenario, deploy it in production. Thanks for joining this presentation, and any questions, please free to add in the chat window. Thank you.